All right, let's go.
Number 10. Stellar black holes, the classic killers. Stellar black holes form when a massive star, at least 20 times the mass of our sun, runs out of fuel and collapses under its own gravity in a fraction of a second. For millions of years, nuclear fusion in the core produces outward pressure. That pressure is the only thing fighting gravity from crushing everything inward. It's a war. Then the fuel runs out. Gravity wins, instantly. The core collapses to a point smaller than a city in under a second. The outer layers explode outward in a supernova so bright it can outshine an entire galaxy for weeks. What's left in the center? A stellar black hole. These range from 5 to 100 times the mass of our sun, compressed into a few kilometers across. Our mathematics produces infinities when we try to describe the center. The equations break, not because the math is wrong, because reality there is doing something physics doesn't have words for yet. If you compressed Earth into a stellar black hole, it would be the size of a marble. Same gravity, same mass. Step within the event horizon and not even light escapes. There are probably hundreds of millions of these in the Milky Way alone. Most are invisible unless they're actively consuming a companion star. Then they glow in X-rays bright enough to see from tens of thousands of light years away. Stellar black holes are the most common type and the least extreme thing on this list.
Number 9. Supermassive black holes, the gods at the center of everything. Every large galaxy we've checked has a supermassive black hole at its center. Every single one, including ours. Right now, 26,000 light years from where you're sitting, there's a black hole called Sagittarius A star with a mass of 4 million suns. And that's small for a supermassive black hole. The largest confirmed one, TON 618, has a mass of 66 billion suns. Its event horizon is so large our entire solar system fits inside it with room to spare. Here's the problem. Stellar black holes max out around 100 solar masses. To grow to 66 billion through mergers alone would take longer than the universe has been alive. And yet we find fully grown supermassive black holes and galaxies that formed less than 1 billion years after the Big Bang. There is no conventional explanation. Something is missing from our understanding. What we do know, supermassive black holes govern their entire galaxy. When actively feeding, they blast jets of radiation so powerful they heat surrounding gas and shut down star formation across hundreds of billions of stars. They're not passengers, they're dictators. Our own Milky Way star formation history was shaped by Sagittarius A star doing exactly this billions of years ago. Number 8. Primordial black holes. The ones that might have built everything. In the first fractions of a second after the Big Bang, timescales shorter than anything you've ever measured, the universe was so dense that certain regions might have collapsed directly into black holes. Before stars, before atoms, before structure of any kind. These are primordial black holes. They didn't form from dying stars. They formed from raw chaos. Here's why they matter. Dark matter, the invisible substance making up 27% of the universe that holds galaxies together, has never been directly detected as a particle. Some physicists now seriously think primordial black holes could be dark matter. The right mass range, the right distribution, interacting only through gravity. We've never proven this. We've never ruled it out. They might also be the seeds that supermassive black holes grew from, explaining how those monsters existed so early in the universe's history. Primordial black holes might be dark matter. They might be the origin of every galaxy. They might explain the biggest mysteries in cosmology. Or they might not exist at all. We genuinely don't know. Number 7. Intermediate mass black holes, the missing link. Stellar black holes, up to 100 solar masses. Supermassive black holes, millions to billions of solar masses. What bridges that gap? Intermediate mass black holes, thousands to hundreds of thousands of solar masses. For years, they were considered theoretical. We had hints. X-ray sources too bright to be stellar, globular clusters with something massive and invisible at their centers affecting nearby stellar orbits. In 2020, LIGO detected two black holes merging and producing a 142 solar mass remnant, first confirmed intermediate mass black hole. But 142 is barely intermediate. We still have essentially zero confirmed examples in the thousands to hundreds of thousands range that should logically exist everywhere if supermassive black holes grew from smaller seeds. They're either hiding from us, or we don't know how to look, or our growth models are wrong. The missing middle of the black hole family is one of the most embarrassing gaps in modern astrophysics. Number 6. Rotating black holes when space-time gets dragged along for the ride. Every real black hole in the universe almost certainly rotates. The star that formed it was spinning. When it collapsed, that spin was preserved and amplified, same way a figure skater pulling in their arms spins faster. Way, way faster. Around a rotating black hole, there's a region called the ergosphere, outside the event horizon, where space-time itself is dragged around by the rotation, not matter, space-time, the fabric of reality spinning like a washing machine. Inside the ergosphere, you are forced to co-rotate with the black hole. No engine, no thrust, no force in the universe keeps you stationary. Space itself is moving, and you move with it. But you can still escape. The ergosphere is outside the event horizon, and through a process called the Penrose process, you can extract energy from a rotating black hole using the ergosphere. The black hole slowly spins down. You get energy, enormous amounts of energy, the most efficient energy extraction physics allows. A sufficiently advanced civilization orbiting a supermassive rotating black hole and mining its ergosphere could run indefinitely long after the last stars have burned out. Number 5. Ultramassive black holes, where extreme runs out of words. Above supermassive, there's a category so extreme it gets its own name, ultramassive, exceeding 10 billion solar masses. The current record holder, Phoenix A, clocks in at an estimated 100 billion solar masses. Its event horizon radius is roughly 590 billion kilometers. The Earth-Sun distance is 150 million kilometers. Phoenix A's event horizon is nearly 4,000 times that, in radius. Traveling at the speed of light across its diameter takes more than 3 months. And here's the strange part. As black holes get more massive, they become less dense at the event horizon. Phoenix A's boundary has a density lower than water. You would cross the point of no return and feel absolutely nothing. No tidal forces, no alarm, just slightly curved space. You could be inside Phoenix A's event horizon and not know it for hours. In the far future of the universe, as black holes merge over cosmic time, the largest objects that will ever exist will be black holes, ultramassive ones, still growing. Number 4. Micro black holes, the ones that evaporate. In 1974, Hawking proposed something that seemed absurd. Black holes aren't completely black. They emit radiation and slowly evaporate. Near the event horizon, quantum mechanics allows pairs of virtual particles to briefly pop into existence. Normally, they annihilate immediately, but at the event horizon, one particle can fall in while the other escapes, carrying energy away from the black hole. Over time, the black hole loses mass and eventually evaporates completely. Hawking radiation. The smaller the black hole, the faster it evaporates. A mountain mass black hole evaporates in roughly the current age of the universe. A car mass black hole evaporates in a nanosecond. A Planck mass microblack hole in 5 × 10⁻⁴ seconds. Gone instantly. When the LHC was being built, some models predicted high-energy collisions might briefly produce microblack holes. People panicked. Would it swallow Earth? No. Cosmic rays hit our atmosphere at energies far exceeding the LHC, constantly for billions of years. If that produced dangerous black holes, we'd already be gone. Hawking radiation has never been directly confirmed. Even the smallest black holes we know about would take 10 to the power of 67 years to evaporate. It remains the most important unverified prediction in physics. Number 3, charged black holes, where causality goes to die. Physics says a black hole can have 3 properties: mass, spin, electric charge. Charged black holes are almost certainly theoretical in any significant sense. Any real black hole rapidly neutralizes its charge by attracting opposite charged particles from surrounding plasma. But theoretically, a maximally charged black hole has 2 event horizons, an outer one and an inner one, called the Cauchy horizon. Beyond the Cauchy horizon, the laws of causality break down. The sequential structure of cause and effect, the foundation of all physics, simply ceases to function. Things can happen for no reason. Effects can precede causes. Most physicists believe in cosmic censorship, that nature always prevents the Cauchy horizon from being reached, that there's a built-in rule keeping this breakdown of causality safely hidden. Nobody has proven this. It's a conjecture, a hope. Number 2, naked singularities, the ones that should be impossible. Every black hole has an event horizon hiding the singularity from the rest of a universe. The breakdown of physics is safely contained. But what if the event horizon didn't exist? A naked singularity is a point of infinite density where physics completely breaks, exposed directly to the universe. No concealment. Raw breakdown of space-time interacting with everything around it. Roger Penrose proposed the cosmic censorship conjecture in 1969. Nature always generates event horizons around singularities. Physics has a built-in modesty filter. But mathematically, under extreme conditions, specifically rotating black holes spun past their theoretical maximum, the math produces naked singularities. What would one actually do? Nobody knows. Spontaneously create matter, violate causality across the surrounding universe, and the predictability of physics entirely. The proof of cosmic censorship has never been completed. It remains one of the great open problems in classical general relativity. Number 1, white holes, the time-reversed black hole. Take all the mathematics of a black hole and run them backwards. Instead of a region nothing escapes from, you get a region nothing can enter, but things pour out. Matter and energy ejecting from a singularity, an event horizon that repels instead of traps. This is a white hole, and Einstein's equations don't just allow them, they predict them as the mathematical other side of every black hole solution. The problem is stability. Any white hole that formed would collapse essentially immediately. They require perfectly symmetrical conditions that never exist in the real universe. And yet, some physicists have proposed that at the end of a black hole's Hawking evaporation, the singularity doesn't disappear. It bounces. The black hole slowly transforms over timescales longer than the current age of the universe into a white hole that explosively releases everything that ever fell into it. Under this model, some gamma-ray bursts, the most energetic explosions we observe, might be ancient primordial black holes from the Big Bang finally completing their evaporation and transitioning into white holes. We haven't proven this, we haven't observed it, we don't have a quantum gravity theory to calculate it, but the mathematics allows it, and in physics, that demands to be taken seriously. The universe didn't give us one kind of black hole. It gave us an entire family of reality-breaking objects at every scale. We've been doing serious black hole physics for about 100 years. The universe has been making them for 13.8 billion years. We are not even close to understanding what these things actually are. Subscribe, drop a comment, which type broke your brain the most. See you in the next one on Cosmic Hives.